Welcome, everyone. This is going to be a great one. I'm very excited.
Fingers crossed.
Sup, Bittensor. So we're going to be talking ridges today. Next week, no team. It's actually going to be an open tensor slot. Do a bit of a checkpoint on detail, talk about some of the changes we're making. I think people are going to be pretty happy with some of the upgrades we're making to the protocol to help out everybody across the board. But that's not. We have Ridge's team. Or is it still Ridges, or are we Ouroboros with this new logo?
Yeah, I think it's no, we're keeping ridges, I think. The snake kind of has ridges too.
The snake slithering along the ridges. Where is that name from? Ridges.
Ridges? I just try to come up with like a generic name. Yeah, like it doesn't really come from anywhere. I do love Ouroboros
like
as well.
it.
I love an Ouroboros chain and like maybe a tattoo.
I think Riches is really slick. 2 syllables, punchy, sounds natural. Right.
I think it's nice. It just doesn't really come from anywhere. It's just kind of made up.
Making up a word. I think it's smart. So, well, I think you're here. Steph's on stage. Mics are checking. We're live on Twitter. Let's get into it. Do you want to share?
It's like a pretty short presentation. Just kind of goes over what we're doing. So basically what we're doing is we're building agents on Bittensor. So the reason we're doing this is that like LLMs are kind of like eating the world of software. Something like 84% of engineers use it as part of like their daily workflow. You have products that are kind of nailing the UX of integrating AI into like what a software engineer does, helping them code and stuff. And there's some of literally the fastest growing companies of all time. Stuff like Lovable, Claude Code, Cursor. Right now, the loop is basically where AI writes some code or edits something, a human reviews it, and then it either checks whether it worked or it tells the AI what it did wrong, and AI kind of like goes through the iteration. But what everyone's kind of working towards is something where the AI writes the code for you instead of like end to end, instead of having like a human in the loop. There's no real reason why a human has to supervise if the AI can also review its own work and check whether it worked. So if you go to the next slide, you can kind of see that everyone's working on a system now where AI writes the code, it reviews it itself, and determines whether it needs to make changes and iterates on it. And basically, every single one of these companies is working on it. It's kind of like that little end, like the design at the bottom that changes. But each of these companies, like Lovable, for example, has their agent mode. Cloud Code is literally just an agent where it's not really doing much supervision at all. Cursor, same thing. They're working on Cursor agent mode. But the idea is that you kind of get AI to write code for you end to end the same way that a human would. So instead of having like a human engineer build the features, test the features, fix the things that break, you can have AI do it. And this is like one of the like very clear like product market fits of AI. Is that like it can write code and they're getting very good at it. There's a lot of training data, and everyone's kind of taking advantage of this. Models have gotten very good. So if you go to the next slide, please. So I just want to like start by like kind of defining what like a Ridges agent is. The idea is that we kind of build a tool where a company can replace an engineer. Either an engineer gets like many sub-engineers that work under them, or like a product manager can ask for a feature, and it's done end to end for them in the same way that a human could. In doing so, it's not just a simple question of asking the AI and it writes some code. There's a lot more that goes into that. Right now, like for example, if a human asks AI and it gives us some code, it has to like figure out how to integrate the code into the code base. It has to check whether it works, whether it's valid code, whether the code runs, whether it actually does the thing that you want it to do. Is it just like kind of random code, or does it fit the pattern of the code base that it's in? So what we're basically creating is bots that use an LLM and embedding models. Like basically, they're using AI models to write working code to solve an objective. So what we've done is we've created like a situation where there's like a mini computer, we call it a sandbox, that an agent is kind of dropped into, where it has full control of the computer. It can edit code, it can read files, it can like kind of figure out the structure of a code base, all the kind of stuff that a human would do in a safe, secure environment. We also give it a code base to work within. Like, so it's like you have this computer, inside the computer is this code base that you need to solve problems in. And then you're given it a problem to solve or some objective, like build this, or like, for example, there is this feature that is not working properly, fix it, that kind of stuff. And so what miners are doing is they're basically building these bots. They're writing these bots that can basically do this end to end, because obviously the miner cannot supervise what its code is doing. So the miner gives us its agent code. We drop it into this computer. The agent, that code that it wrote, tries to solve the problem using LLMs and using its own like logic, and then it returns some solution of code. Either it works or it doesn't. I don't know if that's like clear so far.
It's clear to me, at least.
All right. Can we go to the next slide? So here you can see like kind of an example of the code. So one thing that we've done is we've kind of gotten miners to open source all their code. So it's not like where miners kind of just give us the solution. They actually give us the code and the validators run that code to get the solution. So the miners are kind of out of the loop here. But this is an example. So this is why we can see the miner code, and you can see like there's a bunch of functions that it's doing. For example, it's given the AI the ability to like get the contents of a file, to save a file if it's done after it's edited stuff. Let's say the AI is reading all the file names and it's like, okay, maybe it's in this file. There's a function there that this guy miner wrote for the AI called search and specified file, for example. And all these tools that we're building to give to the AI so the AI can interact with the code like a human would and solve the problem end to end. And you can actually see all the code for every agent on our dashboard right now as well. Next slide.
Just a question about, why not just use MCP with a normal LLM? Like, just, okay, here are the commands you can make with Git. That's fed into the prompt and then passed to Kimi2. Like, why is it required that we write these like agent code bases written in Python? Why doesn't everything just collapse into an LLM at the end of the day?
Because there's a lot of stuff that you kind of have to do and check reliably. So LLMs can hallucinate. And you can also have stuff where like there's pretty clever ways you can chain LLMs together. You can put different models together to kind of solve problems better. So for example, like we allow our miners agents to specify for each thing they do what model they want to use for it. It's possible that some models are better at selecting which tools to use. It's possible that some of them are better at reading code. Some of them are better at like editing code that has already been written, stuff like that. And also like you kind of want to interact with it in a reliable way where like, okay, is the LLM going to open the code and read it as well? It needs like an ability to do that. So I mean, it's kind of like an MCP style structure in this sense. But it's like kind of letting people mix and match things that are best at specific topics, if that makes sense.
Yeah, totally. And is this something like Claude Code? Is that a good reference point for people to understand here what this is?
Yeah, I think that's a pretty good one. Yeah. They've got like a pretty
So,
decent UX.
so what is the difference between an agent here and something like Claude Code or cursor agents? Like how does all that work?
So I mean, fundamentally, it's the same thing, except they are kind of like first of all they're closed source. You can't actually read how they're making these decisions, and for them they usually have like their own custom models that they're doing for it. So it's like a combination of some tooling and then getting their model to choose it first and foremost. In our case, we're trying to like allow anyone to kind of like collaboratively build this, but it's a pretty similar kind of UX where you give like a model.
Yeah.
And architecture.
So you cut out slightly for me there. Do you want to go back and just the last 30 seconds?
Sure. Yeah, basically, like it's a pretty similar architecture, except in our case, like it's fully open source, and so people can kind of first of all like inspect what it's doing, and kind of collaborate on it as well. But it's the same thing where like you basically give a bunch of tools to a model, and the model can kind of like mix and match these tools to come up with a like a solution.
So those tools available to them are the ones that they've written inside of this agent code, but also they've also written or they have access to shoots, correct?
Yes, yeah. Sorry, I don't know if I made that clear. Basically, like you have like a bunch of tools, and you have access to shoots for whatever model you want to use. And then the model basically, you can either use the model yourself, you can either use the tool yourself, like hand code it, or you can tell the model, you can give the model the list of tools available to it and get it to choose based on what it's seen so far, based on the like kind of code that is written, that kind of stuff.
Is there a limit to how many tokens the LLMs are allowed to produce for this?
Yeah, so right now we give the agent around $2 of inference. So however many tokens that is, because some of them are cheaper. And then it can use as many tokens until it hits that like $2 inference limit per problem. Although in practice, nobody's come close to this inference limit. Shoots is like extremely cheap. I don't think anyone's used more than like 2 or 3 cents on a problem.
There's an interesting comparison there with like the hourly rate of a senior software engineer. Clearly, this is going to
Yeah.
be way cheaper if this, if this is able to sort of keep up with that quality.
Yeah, for sure. We've used, I think, as of this morning was 9.5 billion. I think it's probably close to like 10.2, 10.3 billion tokens in the last 10 days on our subnet. And that's across evaluations for hundreds of agents over the past 10 days. And all that together, like over 10 billion tokens, has costed less than 3 grand.
Wow.
So for reference, that's like 400 agents times 50 questions per agent times 6 validators. That's 120,000 problems solved for less than 3 grand.
Wow.
And
Well,
the agents are working on multiple problems at once, or each miner is sort of assigned to one specific problem.
They're working on multiple. So the way it works is that when a miner submits their agent code, all the validators kind of pick it up and they run it on 50 problems, from easy to medium to hard. And then it kind of like creates like a total score. But it runs 50 problems in parallel. We built like a custom sandbox for it to run in. That was secure and also lets it run like this many, I guess like problem sandboxes on one validator machine at the same time.
Is there a maximum runtime for the sandbox?
Yeah, we give it 20 minutes before it times out. People do hit
Cool.
that actually.
For sure.
wow. And they can query any model on shoot. They can query like hypothetically, right? They can broadcast broadcast LLM queries to DeepSeek and Kimi and any model on shoots, correct?
Yeah, and we've actually like over the
All
last
at the
couple
same
days
time.
noticed, yeah, any model they want. Well, we create like a whitelist of models to avoid someone training like a custom model on our problems and then uploading that as the model. But every major model we add it like right away, and the miners pick it up as soon as Shoot supports it. So they're using Kimi K2 is like the most popular model right now. They also started like using Quen, the new one that Shoot's put up. Um, yeah, they can use basically like any major model that they want, and if it's not supported, we basically add it to like that list of models they can call.
Very cool. Well, we've derailed you now for 10 minutes. Let's go to the next slide.
Oh yeah, so this is our team. It's basically myself. So a little bit about me. I graduated when I was 15, and then I went to dental school, and then I kind of completely changed careers because I went to dental school right as COVID started, and I kind of started programming just on the side. I preferred that much more, so I dropped out of dental school. I was an early engineer at Supabase. I also did a lot of HFT stuff, and I worked on the transition team at Twitter. And I have like 3 Waterloo engineers with me, and we all just kind of stay in my dad's basement and build us out of there. But it's completely voluntary. Nobody's being forced to stay in my basement. But yeah,
Wow. Well, that's the best way to get things done, I think.
for sure. Yeah, it's pretty cool. It's a vibe. It's like like we look back on like a week ago on the code that we wrote then, and it's like completely different. I think if you look at our code base, almost no code exists from 3 weeks ago, and it's like yeah, like the code turnover rate is pretty crazy. It's a good time. It's also like I didn't mention it as like a crypto thing initially because I think Bittensor is like one of the only places in crypto where it's not like a scam. So people have like an aversion to crypto. So I mentioned it as like competition markets, and then slowly everyone kind of got more Bittensor pilled, and I think the whole team's kind of like really bought in now.
Well, it depends on which subnet. Sometimes they are.
Yeah. I mean, they enjoy our submit. It's very cool. Kind of like we adjust the incentive in a bit, and then we see how the miners respond. And they've kind of gotten to that point now where they're actually like improving the agent a lot. I think the next slide actually shows. I think it's the next slide or the slide after that shows like the performance graph. Oh, okay. But yeah, so basically like we had. I'll kind of talk about like our incentive a bit. We changed our incentive quite a bit. So a couple months ago when we started, it was a pretty standard thing where the validator sends code and an objective, and the miner just sends a solution back. Obviously now you can see the miner code so that's changed quite a bit, but this had like a bunch of problems. So if we want to build like a product that people use to replace engineers, no sane company is going to send their private code bases to like random miners. There's like a major privacy issue. And so having the miners as a black box that just receives the code base is kind of an issue. There's also a problem where like it was very hard for people to compete because we had some dominant miners that had written decent agents. But the problem was that like any new miner had to like start from scratch. They had to reinvent the wheel. And this is like a problem because um, we're competing against the top labs who are all kind of like working inside, of course, but like they're all working together with large teams to like try to build these agents out. And there's like clearly like a product market fit here, and there's a race to build like a good product. And it's hard to do that as like a solar miner. Like the whole point of collaboration is not really possible if every miner has to start from scratch and reinvent the wheel to get to the same optimizations. So there were a bunch of problems that we had with like this old model where the validator sent like some code and a problem, and the miner sent back some solution code. So if you go to the next slide, I talk about like our new incentive. So we decided to kind of like flip the script and like this is actually your idea, but we make miners fully publish their agent code for everybody to see. So the miners basically publish their code instead of the validator kind of like evaluating just the solution. The validator now gets to run the agent code themselves in a bunch of problems, and then they basically get to like check the output of that agent for themselves. And so the new miners are basically whenever someone comes in to start mining, they get to build on top of the best in class code because they can see everyone's code, they can see who has the highest score and start from there. Um, and and so what that means is that like whenever someone comes up with an improvement, it's kind of absorbed by the entire ecosystem of miners. So for example, like we've seen that whenever somebody comes up with like a better way to read context, like to figure out where in the code to edit, and that leads to like an increase in their score. They publish their agent code, all the other agents within like a couple hours have kind of picked that up and now include that innovation in their agent code. Another agent, for example, created this really cool thing last week where they used like trajectories. Like the agent plans out in advance how it wants to try to solve the code, how it wants to solve the problem, and that led to like a huge performance jump in how many questions the agents were able to solve. And that was also picked up by all the agents across it. And so basically, it's now competitive because whenever you publish your code, the clock is ticking. Everyone's going to take that, but it's also collaborative where everyone's kind of like leveling up their agent together, and any improvement to any part of the agent is used by everybody to improve everyone's agent at the same time. If that makes sense.
If I'm going to put my red hat on for a second, so I guess one thing that we saw in the previous version of Subnet 9 is like miners had to upload their models to be eligible to get rewarded for those models that they trained. And in your case, it's a similar structure. But what stops miners just aggressively obfuscating their code? Like they actually kind of want it to be as useless as possible to everyone else so they can keep their advantage.
Yeah, they do this. They do this a lot. We have like a bunch of stuff in their code that kind of like deobfuscates it. So, for example, we built a dashboard to explore the code where we provide like a tree of all the code and the functions it calls. So you can't just be calling random stuff. Um, any dead code like is stripped out. There were people, for example, that were like hiding a lot of their code in binary. We just don't allow that. Like we should have banned the miners for doing that, and that solved the problem for us at least. It's a little bit harder to hide because um anyone can kind of just reverse it. It's like pretty trivial to like reverse some of the obfuscated code, and we require the code that the miners submit to adhere to certain standards. So, for example, there has to be an agent main function that takes in a code base and a problem statement, and you have to like so that's like a starting point that any miner can see and kind of like click through the code to see what they did, if that makes sense.
I mean, you could you could also use things like FMT rules, right? You could be like it has to be properly coded,
Yeah.
formatted code.
Yeah, you could use static
Um,
type checking and all kinds of stuff there. Yeah.
Yeah. We haven't had like a problem of like so we've had a problem of people obfuscating like cheating, where for example like one agent looked at our problem set, they came up with answers that would work for all of them by hand, I guess. And then they submitted like an agent that looked like a real agent, but there was one line there that was binary. And then what their agent would do was that it would take that binary code, it would decode it to get the answers for each problem and submit it, and then score like 100%. But luckily, no one that's like trying to do like any crazy obfuscation on the actual agent code.
Is there a limit to how big the agent code can be?
Right now we have a file, like a limit of around 2,000 lines. But we're increasing that bit by bit. Like people do ask to increase it, and we do.
Yeah. So, and okay, so if let's say Const and I are both mining Subnet 62, Const works
Which we are.
diligently for weeks.
Yeah.
He works diligently for weeks, and he comes up with an excellent solution. And then all I do is I just change something really superficial. Maybe it's a word in a prompt,
Mhm.
or it's, I don't know, just something that's like not really like intellectually valuable to the product. Would I just become the winner and he would get nothing?
No. So we did two things for that. Number one is that like we require you to be the previous. This actually did happen where like some guy, the guy that created like the trajectory agent architecture, where the agent pre-plans what it's doing, spent like a month on it. He said, and then someone basically scored a little bit higher, and he was worried they were going to get weight. But we were basically require you to like have a score of 1.5% increased from the previous one. And in our testing, that's like outside the range of just trivial edits. So you have to at least make like some real logic improvement to the code. We are considering doing some stuff where like perhaps that like for example we hide the top Asian code for some time just to give them like some incentive before they can kind of get overtaken as well. But this is kind of by design. We want people to come up with improvements that like they do get paid for. So unless someone can actually substantially improve your code by and improve the score by 1.5%, they don't get incentive. But eventually we do want everyone else to actually pick up on your edits and improvements to create like a better agent.
That's super cool. I'm
So,
stoked.
so there's like an epsilon here. You have to improve upon the previous score by some amount before you're considered to be the top.
Yes, exactly.
Subnet 9 strikes again. What is that epsilon?
It's currently 1.5%. That's like outside of our range of like error in our testing.
Interesting. So
Um,
That's
economically,
global
this
value. Go ahead.
that's a global value. Yeah, you guys know about that, Stefan. You probably have some ideas.
Yeah, 1,000,009%. I can
Um,
work with that.
when we're looking at this graph, this time series here,
yeah.
the top miners, pushing these improvements. What does that pay out per? Well, I guess right. It's like 100% of the miner emission for those days that you're on the top, correct?
Yes, exactly. And if you look at the chart, people are usually on top for a day or 2 days. So, for example, like the guy that created the last major performance increase, I think made like roughly $30,000. It's like around $15,000 a day, and it goes 100% to the winner. It's a winner takes all model. So it's quite lucrative. So even if you work for like 10 days, create an improvement, and you're on top for like a day and a half, 2 days, before someone else can like create a substantial enough improvement to get on top, you made 15 to 30K, depending on how long you were on top.
Do you know about who your miners are and like where they're coming from and where they're getting those architectural improvements, like how they're achieving them?
Yeah, I actually talked to like most of the miners. I think at this point we have like I think 8 unique miners, or miner groups that I can like name, um, and like they're kind of from all over the place. There's like one that's like a pretty large team of like 11 that's working on it. There's another one that are like just kind of solo people, like working on it. Like some from Washington, some from like different places. There's a lot of solo miners. This one guy in particular, I don't know his background, but he seems like a solo miner that's created some. He's like full-time mining 62 and created some of the biggest architecture improvements. It's actually pretty funny. Some of them start like arguing. I remember one miner sent me a screenshot of what another miner sent them, where like they were like basically like just like harassing them, I guess for like beating their agent. I'm not sure.
what what are some of these architectural improvements that you've seen? Like,
There's a lot of really
what are these
cool.
innovations?
So, for example, there was one miner that instead of embedding the whole code base, would like strategically embed parts and then do like a comparison to see like the most relevant parts of the code to the problem statement. So we let agents use inference. They can like ask like LLMs basically. They can also use embedding models, and that helped it improve the score by I think 6%. Where it basically like was able to narrow down what to look for and kind of get like much more accurate at where to solve a problem. The other big one, for example, was creating like a trajectory, like it basically pre-planned what it wanted to solve, and so like it could kind of follow steps and then go back in its steps and see what it did right and wrong and improve its steps as it went along. There's a lot of really cool ones. Another one was um, like basically going through the whole code base before it started solving the problem and creating hints about what the code base was about, and somehow that made the LLM more likely to produce valid code, that kind of stuff. And this is all
That's
like
really
within the
interesting.
last 10 days. Yeah.
And so, do these like that hint design or the embedding design, they get carried through to the next miner, right? So somebody
Yeah.
invents that, it stays there, and then somebody invents another architectural improvement, but keeps the previous one. Is that how that works?
Yeah, exactly. It's actually very cool. It's like a little organism where the moment someone publishes something that like improves the agent performance, um, within like 6 to 8 hours, all the top miners have basically published some version of their agent that includes that logic too. And it's not like they're just kind of like forking off the top agent and improving it from there. They're actually looking at like the agent logic and trying to integrate that logic into their agent, and resubmitting their agent with that new kind of improvement to try to like get back on top.
So
And
right now,
any hints of? Oh, go ahead, Stephen.
yeah, so right now the best possible agent is something that can reliably score super high on bench. Is that right?
Yes, but only for a little bit. We're actually introducing polyglot and like a synthetic eval as well. But right now it's like a selection of sweet bench problems.
For sure. Yeah, and that makes sense as well. I totally understand that decision, but I guess the really ambitious play here is like what guarantees do you have that when you go from sort of synthetics and benchmarks to organics and real people, like someone shows up and they're like, yo, make me a landing page, or yo,
Yes.
help me, help me do this thing that's a bit more out of that distribution. How can the network be oriented towards that? Because you could articulate that and you could get the miners to train, but then it's only going to be as good as how well you can evaluate that. So you're going to need some sort of figure of merit for whether the miners are doing a good job.
Yeah. So we have like two things for that. This is actually like a problem where if you look at the top agents on every benchmark and you try to run them on another benchmark, you see a problem where they just don't do that well. So the reason why we wanted to like a combination of benchmarks was to kind of like try to solve that in part, where like now to like do well across all the benchmarks, the idea is that like basically roughly the top agent moving forward is the top agent across all the benchmarks. So if you're really good at one benchmark, but you're not like a generally capable agent that can solve these other ones too, you're not top agent. And so the idea is that like by forcing agents to kind of solve multiple types of questions, the best way to win that is to build a more generally capable agent that's like really good at reasoning and iterating on itself, and therefore should be good in prod. The other thing is that we're basically working to build like an MVP as fast as possible of like a legitimate cloud code competitor that you can try. And then we can start moving emissions there as well, where like your agent can be A/B tested with usage, more usage, and like more actual like feedback, like positive feedback for your agent gives you a higher weight. So like real world feedback, we actually try to throw it at these kinds of problems, and if you're better at solving these kinds of problems, you win. And then that also sets up like a feedback.
Oh, hold tight. Did we lose him?
We lost him.
Obviously, there's yeah, and then we can kind of like add that to like our kind of like eval set, as part of the eval.
Well, I want to ask questions about that, but is that coming later in the slides, and should we go forward?
Yeah, it comes later in the slides. I just want to show this graph though. Just one more thing about it. So we basically have this architecture where whenever the miners get really good at one set of problems, we re-up the problems and then reassess all the miners, all the top miners on them. So we did a reassessment about like 6 days ago, 7 days ago, and the top miners at the time were pretty overfit to our problems. And I think I mentioned this problem to you. We had like a problem with overfitting. We reassessed it on a much harder set of problems, and the score went down to 4% of problems solved. And since then, like the agents have started actually improving like their architecture. In the last 10 days, we went from 4% of problems solved to 41% of problems solved as of this morning. So
Wow,
it's
right.
pretty
This is only
incredible to
10
see.
days.
Yeah, less than 10 days, like 7 days, I think.
Amazing. Congrats.
Yeah, the miners are phenomenal here. And it's actually like you can read the code and see the stuff that they're doing to lead to these performance improvements, and it's just like really impressive stuff. Um, yeah, it's very cool to see. Like every day you wake up, you check the dashboard, someone's on top, someone new is on top.
And another question about what resources the miners can use. So there's just a set of whitelisted libraries in Python that they're allowed to use in their solutions.
Yeah.
Cool.
Kind
Right.
of. So we have a new product releasing today. It's like actually on a later slide, where we now basically create like a sandbox for them. So in addition to that whitelist of Python libraries the agent has access to, we try to simulate like a real world environment where Each mini computer, the sandbox that we put them in, also has access to all the libraries needed to run that code base. So where before people couldn't actually run their code to check whether it worked, the agents couldn't run their code. They're now going to be able to do that. Starting now, it actually just went live.
In a future state, can I come to your platform and just build like a world-class chess engine based on an LLM and a few lines of code?
I don't. Well, sorry. What do you mean by that?
Like, does this generalize to something that can also sort of do algorithmic stuff that's not necessarily the daily grind of a software engineer, but like I want something that can play Pac-Man to expert level. Could a system like this take in the state of a game like Pac-Man and an LLM and reason its way through, do you think?
I think so. I don't see why you couldn't kind of do the incentive as long as you have the right eval, and like kind of do this model where you pull their code and see how it does in a sandbox. It could generalize, I think. Right now we're just doing software, but I don't see why you couldn't do that.
How about a company like Lovable? Is that also sort of in the lens of Ridges?
Somewhat, yeah, yeah. They have like a really nice UX where you can actually see what's going on, but it's the exact same thing where you have an agent, it has access to tools. Lovable is particularly like tuned towards like front end stuff, and they have like a framework that they get to start it in. But yeah, it's like a similar kind of tool. It's a competitor for sure.
When when these best agents become best in the world, um, how do you intend to maintain that IP or associate it with the token economics of your subnet?
So we have two things. One is that like obviously we'll have like the whole like legal kind of like notice that you can't use these for commercial purposes and stuff like that unless you're using it through our product. We're going with like a more like I guess like commercial open source playbook where like anyone can read the code, same as like Linux. Anyone can run it themselves. But for companies that actually want to and wouldn't kind of like go step over that like I guess like legal threshold, we can create like a white label product for them. Where we basically handle like the whole pipeline of looking at these new agents coming in, assessing them, making sure the agent code is actually better and not doing some sort of exploit. And then for the user, just kind of swapping out the agent under the hood. So now every time a user uses the agent, it just gets better, and they don't have to worry about hosting it. They don't have to worry about like hosting any inference, that kind of stuff.
Interesting.
We
Makes
have
sense.
a question from Sedant. Why don't you compare with Claude Code or maybe Quencoder?
I think Cloud Code is still better than us, but I think that like at this pace, it's reasonable for us to create something that can match its performance. Cloud Code was able to solve 73% of Sweetbench verified problems. Granted, our problems are like a subset right now of Sweetbench, just because we don't want to run like 500 Dockers per agent. But I think that as we can probably start to come approach them. For now, it's better, but I don't see that lasting for terribly long.
I think
Next
a
slide.
question, one more question for me, and then I'll let you off the hook. I think from the validators in the audience that are probably wondering, how much does it cost to validate this if you have to run all of these inference steps on so many different problems in each round?
Sure. So right now we actually host the inference ourselves. So the way it works is that the miners upload their code, the validator pulls the code and runs it. But the agent sandbox has access to basically only 2 points of access to the internet. One is a link to an embedding endpoint that we host, and one is a link to an inference endpoint that we host, where we basically validate the validator hotkey that's trying to request our server. So the subnet itself hosts all the inference and embeddings for the validator. The validator basically just has to pay for a machine to actually run the sandboxes for the agents. And the sandboxes are really lightweight, so you can run an agent on 50 problems on 32 gigabytes of RAM and around 512 gigabytes of storage. We did this because we wanted it like to be possible for like we wanted to really lower the barrier of entry to miners. So we built like a bunch of tools for miners, but one of the things we also focused on was making it very easy for them to run the whole flow locally as well. So yeah, to answer your question, the validators have no inference cost. But even for us, over 10 days, it's about 3,000 of cost for 10 billion tokens. It hasn't been terrible.
Super cool. Nice solution.
And we're actually planning on load balancing today as well with like Targon. So we can kind of like use both subnets for like higher inference usage. Especially because like Shoots is scaling up quite fast. all the like for example, right now the model that the AI agents love to use the most is Kimi to instruct, and so they've set up nodes for this to like try to spin it up as fast as they can. But at this level of throughput, it's hard to like kind of keep up with it. So we're kind of like we're load balancing there to make sure that it's as reliable as possible.
So cool to see this kind of subnet interconnect finally happening on Bittensor in a sophisticated way. So you'll be load balancing between these two subnets on Bittensor to see which one can suffice in terms of the number of tokens you need.
Yeah, exactly. And then like so we kind of like we start with shoots, and if for example the miners are overloaded there, then we fall back to like Targon, and we'll probably do something where we try balancing between both to see what the best solution is. Ideally, like when we get a real product, we still want to keep all of our inference on Bittensor. Um, Especially like for a lot of reasons, the unit economics are a lot better, but also it's just like cool to kind of like build within the ecosystem. And so once we actually start having a product that real users are using, we'll need to like kind of like serve these inference requests reliably between both. But yeah.
Cool. Next slide.
Yes, please.
Onward.
Okay. Yeah. So I mean, there were some kind of like I guess upsides and downsides with going open source. The exploits just became like a lot more embarrassing because it went from something where people can kind of look at the minor weights and go like, "Huh, that kind of looks wrong," to everyone can actually read the code that's exploiting us, so they can read what someone else figured out to like break our code. So we had a few examples of this. Some were explicit, like people would hide the answers to the problems in binary and then get their agent to like not actually do any work but just decode the answers. We banned all of those, and like people just stopped doing it after they got banned. And then there was another one which was like a little bit like gray area. What we saw were on our problem set, on easier problems, it was usually one line of code edits, and a lot of models use SweBench as like part of their training set. And like I think that some of them actually use like the actual like full set as their training set, and so a lot of these models actually had the answers in memory. Obviously, if you were to take an agent, it wouldn't have the answer in memory because it doesn't know what the answer is. You have to actually use the agent to figure that out. So a lot of agents, what they were doing was that they would basically ask the problem directly to the LLM, and the LLM would give a code response. And all the agent would do was just format it well to make sure that the code was like applied properly. So basically, like the model just returned the right answer from memory, and the agents were just formatting it. We've done like a bunch of like we changed up basically the problem set, and this is where we kind of created this whole like problem set upgrade architecture that lets us easily swap out the problem set and reassess everybody. And so we've selected now for problems in our problem set that have like edits across multiple files or across multiple lines that is harder for an LLM to just one shot the answer. It's also there are some upsides because everyone can see the code. The miners basically like report the exploits to us in the Discord right away. As soon as an agent is doing something dishonest, trying to cheat to go a higher score, they tell us they're like, hey, like fix this, and we do. In the past like month and a half, we've had like I think almost 1,400 commits on our GitHub. This is after we rewrote the code base from scratch, so this is a completely fresh code base. And you can read all the top agents now. Every top agent is like an honest miner. They're actually like legitimate code. You can read their code themselves at our dashboard at ridges.ai/dashboard and see for yourself that it is actually solving the problem correctly. We have a very easy tool that lets you download the agent code and use a CLI to one line test the agent and verify its performance yourself, all that kind of stuff. So it's gotten pretty stable now. It's cool to see.
I think there was
Can I?
there was a Kaggle Grandmaster. There was like this big outcry because the Kaggle Grandmaster was caught hiding binary in one of his solutions as well. I remember this. Maybe
Yeah.
the same guy was in your code base at some point. I've
I
got the
wouldn't be
link here. I'll drop it in
surprised.
the chat. You're attracting Kaggle Grandmasters. You're onto something.
Someone did exactly that. They had the answer in binary. Ooh, one really clever guy had an agent that actually tried to solve the problem. So he took the top agent that could solve some of the problems, and he put one or two answers that the agent wasn't able to get in binary. So it was hard to detect that they were kind of like getting like just that extra bump in score. But yeah, it's pretty crazy. It would be cool if it was actually the
So,
same guy.
so you can use a CLI to download the best agent, and then can you just run it on your code base?
Yeah, exactly. You could. There's no reason why you couldn't run the agent right now on any code base.
Can I install it into Cursor?
We don't have an extension, but we could totally build that. I will say though, like agents are getting better every day. Right now they're solving 41% of our problem set between easy, mediums, and hards. So I think like, but yeah, we can totally build one. It's pretty trivial because it's like a unified agent spec. The agent code can run pretty easily. You can use a CLI to run it, and we could totally like, I guess like hook it up to like a cursor extension where it just reads your current code base that you're in, the same way that Cloud Code does.
We have another good question from Siddhant in the audience, actually. He's talking about
Sure.
using a much smaller base LLM so that you can sort of run this on edge devices or generally just way faster. Have you
Yeah.
looked at constraining it so that the LLM has to be as small as possible so the system just can run way faster?
We haven't. We kind of want people to like swap out. So there's like two major sources of performance bumps. One is like people improving the agent logic, and two is better models coming out. And so we kind of want people to like build the best agent possible and get competitive in prod. But it is a good idea to like try to create like maybe like a sub competition where people try to take the top agent and then optimize it for a smaller model to run on the edge. Currently though, like we're kind of encouraging people to use the latest model and like adding support for them as soon as they come out to like give them like the best performance possible. We do see that where someone creates like a previous agent, like takes like a previous agent architecture, and then when a new model comes out, they just submit it with this new better model, and all of a sudden the performance gets bumped.
So, but it doesn't really matter to run on edge devices because you're querying shoots and the agents are all using a remotely hosted LLM.
Yes, exactly. Yeah, they're running on shoots as it is, and it's quite cheap. It's extremely cheap. You can see on the dashboard as well the usage and like how much it costs.
I think it's quite interesting that you could potentially use a variety of different models. Like Shoots has everything available to you, so these agents can, spawn Kimi and DeepSeek and Quen and Gemma all at the same time. Whereas I don't think that something like Claude Code or even Cursor agents don't do that
Yeah,
or can't
yeah,
do
it's
that.
actually very cool. We do actually see that. Like, so, for example, like we noticed that people use Kimi because with the amount of requests that we're doing right now, I think we're actually overloading Kimi K2 on shoots, and so they'll use Kimi K2 for the really time, like for the critical parts of it, where it's like writing code, and they'll use stuff like DeepSeek, for example, to like filter down files for what they want to look into. It's actually very cool. Sorry, am I cutting in and out?
You're not. You're not. You're not. I was just waiting
Oh,
for you here. So it exploits embarrassing. Um, should we jump to the next slide here?
yeah, please. Yeah, so this is like an overview of our new architecture, basically, where the miners submit their agent to our platform. This is like perhaps too in depth, but the miners submit the agent to our platform. Everybody can read the code that's on the platform. Um, Whenever a miner submits an agent, we send it to the validator, who then runs it on their 50 sweet bench questions. Um, And right now we just evaluate it on the score that it got, like did it solve the problem or not? But we can also start evaluating it on like the tools that it used, the inference performance, how many calls it made, that kind of stuff to kind of differentiate as the agents start to kind of come closer to neck and neck. And then the validators then post the weights to the chain whenever there's a top agent. As well, like users can use the product because now through our platform can host it for them in like a Cloud Code style thing. In fact, I can probably put like a demo of that together this week. And miners as well as researchers can read the top agent code. They can pull it and run it for themselves to verify the performance. They can actually, so we actually show on our dashboard the agent inference request as like an iMessage chat. So you can actually see the logic of how they kind of came up with their solution back and forth between the agent and the model. And they can, of course, like see how the competition is developing better agents. I think it's very cool because it's like you can see chronologically how like this incentive mechanism and how Bittensor has brought all these miners together to like iterate and improve on the agent code live to come up with this higher and higher score of like of how many problems it can solve and how well it can solve them. Um,
I think
Positive.
my unsolicited advice, or at least my opinion on the idea of like making the landscape more complex and higher dimensional with all these different factors, I think that you guys have got it pretty clean right now. I think that like
Mhm.
the more axes that competition can happen, the more exploits can happen. You don't really if you just say like I don't care which model you use, as long as you're within these constraints, it's a 0 or 1. You either get the question right with the resources limit or not. I think
Right.
that's probably going to make your life way easier, would be my opinion, rather than give the miners all of this space to like do all of these clever optimizations across two different axes at once. But Const, what do you
Right.
think on that?
I mean, I think that the most important axis is simply performance. You know me, I'm myopic in that sense. And you can go for you can try for cheaper inferences later.
Mhm. Yeah, that's fair. I mean, we're not doing that right now. It's like but yeah, potentially like we'll just kind of let them try to get a higher and higher score, um, and then focus on optimizations later. But yeah, it's pretty cool. One thing I want to mention about this is like it is a pretty complex flow for miners to run locally. Like we noticed that miners are having a hard time because now you basically have to set up a copy. If you were a miner before, you had to set up a copy of the platform, the validator, a proxy server for your inference, all these sandboxes. You have to get your Docker working. And so we basically created like a bunch of these miner tools all across. Like most of them are deprecated now as our code base has changed. But like the newest one, for example, is like a CLI where to get started as a miner, all you have to do is just like write some agent code that adheres to like our agent spec, which means you have a Python file that's under 2,000 lines and has one agent main function, and you can run it end to end with a one CLI call. So it's like very easy to like kind of test and get started as a miner. You can pull the top agent. You can run it with rigid CLI test agent, and it'll actually like pull the sandboxes for you and do everything for you in one shot. So this is like the production incentive mechanism. But as a miner, if you want to get started, it's much easier than this. It's literally just like you write your code in a Python file, and then there's a CLI to give you that gives you one line for you to test how it would do in production.
Brilliant.
Ne- yeah. Next slide, please. Okay. So I also want to talk about like how we're kind of like using Bittensor and how it's kind of been like a superpower for us. This chart shows the total tokens that we've used for inference over the last, I think, 10 days. And you can see that it's just like gone exponential as the miners are like coming up with new architectures. So that there was a big breakpoint, I think, 3 days ago, or sorry, on July 18th, where some miner figured out that they could kind of go back and forth with the LLM a lot more and come up with a better answer than kind of trying to one shot it. And so you see that they started using a lot more inference. In the past 10 days, now we've used over 10 billion tokens of inference, and we've had no hiccups whatsoever. Shoots and like now today Targon as well is basically handling this with zero downtime. And as the miners kind of scale up, the shoots miners are also scaling up their machines to kind of like handle all this extra load. It's over, I think, definitely over 1 million unique inferences, probably a lot more now. And yeah, we've been able to kind of like scale up how many evaluations we do. We've doubled the number of questions that we're evaluating. The miners have like 15 times the number of inference tokens they're doing for each kind of like evaluation, and it's been completely absorbed by the network. We haven't had to like kind of rely on a third-party API at all, which is very cool. And I think that like this will kind of like build on itself, where over time, if you're a user using the Ridges agent for your code base, every day you log on, and like we've swapped out the underlying agent because someone came up with a better one. So the agent logic has gotten better. Below that, the miners on Shoots and Targon have also swapped out to better machines that can do higher throughput faster, because they're also getting incentivized to do so. And under that, there's obviously like models that are being trained, and ideally, like one day we can use a BitTensor powered model to do the actual inference itself, and those are also getting better. We're kind of like tying in all these things together across the stack to create a better product for the user every day. And it's not even just like there's like a very clear reason for why it would get better every day, because everybody working on every layer of this is incentivized to improve it every day, and like they are improving it every day.
Oh yeah. So when you go to more environments outside of Sweetbench, this multiplies, correct? Like we just have to run even more Sweetbenches or polyglots, etc. And these are all coming in, right?
Yes. We have like a method of kind of not scaling up to too many by looking at problems that everyone can solve, like that are easier, and then we cut them off and replace them with a harder set of problems. So everyone kind of has to scale up. But yeah, we're also gonna have to add a lot more questions in the future to get like a much more accurate picture, especially as we add like multiple evals. So we have Sweetbench and then also Polyglot and our synthetic evals.
How do you build a synthetic benchmark that and how does that work and how does it interact with Sweet Bench?
So, I mean, our template for this right now internally, and we're still working on it, is something that looks like Cbench. So we look at a lot of GitHub issues and we try to um, basically just clean them and figure out which ones are good, which is how Cbench was built. And then the other idea is that like you kind of like you can for different kinds of problems kind of create the problems and then um, it's a question of whether the miner can reverse engineer the solution. So for example, like let's say I take a valid code base and I use some sort of like library that can break parts of the code base, both with rules and with an LLM. So like you intelligently break parts of the code base, you rewrite some of the code so it doesn't work as expected, and then now you verify that by seeing that tests in that repo failed. And then so now you have basically like a problem statement, which you can generate from an LLM saying that, okay, like kind of like we have this part of the code that is not working. You have some tests showing that it's broken. And then it's up to the agent to figure out how to kind of reverse that situation and get back to a valid code state. Um, there's a bunch of problems with this that we have to figure out. For example, one is like a lookup problem. So if we're taking a code base, breaking it, and then giving the broken version to like an agent to fix, um, an agent could try to like look up where that code like the valid version of the code base. With open source, these kinds of exploits get a lot harder because we can actually read the agent code and make sure they're not doing this, and they don't have access to the internet besides just inference and embeddings. But we kind of want to get it right, so we're trying to like basically expand the Sweetbench eval set with similar types of problems.
Right, because this is a massive problem in just the general industry, right? People are getting 80% on Sweet Bench, and it's partly because the data set is it's being subsumed inside of the LLMs that are competing, right? They're training on the data itself. Like Sweet Bench is now public.
Yeah, exactly. And so it's like they're not
So it's
so
not
it's
just
like really not like a reliable benchmark anymore.
When you say that because the miners have to share their code, you can check it. Like, do you actually audit everything that goes through the network, or at least the winning submissions?
Yeah, every submission that comes close to the top, I or someone on my team reads. Usually multiple of us read it.
Well,
It's so we also kind of limit the code to be in one file instead of then providing an agent code base because it makes it a lot easier to do this. This is actually like thank you, Cos, for this idea. I didn't know why you were suggesting this at first, but it like definitely saved us with all this code that we're reading. So it's easy to kind of like jump around and see what they're doing in the code because it's one file is under a couple thousand lines. Um, but yeah, we read all the code.
right.
that was my idea. I'm a big fan of small code bases, Stefan.
Yeah.
You know.
We also use like AI to help us. Like if you look on the dashboard, every agent now has like an AI generated summary of what it's doing as well to make it easier even for like miners to try to figure out what's going on.
Should we go take a look at the dashboard on my screen right
Sure.
now and see what we can see?
Yeah, happy to. Fingers crossed it didn't break. We just merged another change right now as well.
You
Okay,
are
so we
fearless,
go
man.
to where we go,
Um,
Ridges.
Bridges.ai/dashboard.
Here we are.
Sure. So the first part shows like a graph, and you can kind of hover over it to see how like per day the agent performance has changed. Um, so you can look at the top score on our platform was 4% on July 14th, and then on 15th it bumped up, I think a little bit above 15%. We're currently sitting at 41.2% for our top agent. That spam down there, this is a live stream with WebSockets of what the validator is doing live. So it's just created a bunch of sandboxes for this agent. You'll see like different validators, like kind of like, so that one started an eval. Oh, that's a pass. So if they pass the test, it's green. If they fail it, it's red. You get like a live stream of what's going on. You can also click into any agent. So if you scroll down, you see the top agents. Some of them are pretty inappropriate, so please excuse that. We let them name the agents whatever they want. But so you can see on one hand the code, and if you hit full screen there, it'll actually show you the code in a full editor. So you can like click on functions. If you look at the on the left side, there's a search function. If you look at agent main, that's the starting function for where they kind of write their code. And this is the real agent code that the validator is running. So you can see all the functions that they have, the logic for how they're getting the LLM to call the tools, all that kind of good stuff. This is like a full view in browser of all the code.
Wow. And so this whole agent is about 800 lines, and
Yeah.
the miners are in here and they're just editing little things. So what? Take us to a point where like a line that a miner has changed here to
It's
improve.
completely rewritten. So our base agent and this agent are completely unrecognizable to the point now where like we have a cron job that looks at the top agent on our dashboard, and in our GitHub we changed the base agent out with that one, because it's completely different. So this agent, for example, I can explain to you what it does, but like it's all new architecture. Um, the last big performance jump I think was from 24 to 36%. The agent that submitted the new architecture simplified it from I think around 2,000 lines to like 500 lines, and I guess this is someone that's building on top of that.
Is there any way you can
Beautiful.
actually look at the diff size? I guess as long as you know everyone's working from the same starting point, you can sort of look at how large a diff is and look at how big the performance improvement was. Maybe there's something interesting there. Maybe you just got some pretty plots out of it.
Yeah, we do actually have that feature. So we have like we have a page coming where you can compare two agents. Right now, we also have a page where you can compare versions of an agent, because miners can upload updates to their agents, so you can actually see that diff in the dashboard of like two versions of agents and their scores and what they change between versions.
That is awesome.
Yeah. If on the top there's a button there that says Show Agent Summary, and that'll give you like an AI generated summary, of what this agent does.
Cool. Explores
And
code space, analyzes problem requirements, plans modification, applies targeted, apply edit code. Key feature: multi-model retry system with agent models rotation, and exponential backoff handles API failures and rate limits. Robustness, comprehensive JSON parsing. That's really cool. So it rotates through a set of agent models. Here we go.
yes,
So it's
exactly.
using two.
This is
Beautiful.
interesting. Everyone started using the same prompt with like these emojis. I'm not sure why. Well, I'm sure why, but like it was interesting to see. And you can also see on like the right hand side the questions, like the code that this agent wrote to try to like solve problems. So we had an issue where miners were like, because each evaluation takes some time per validator and a validator is only evaluating one agent at a time, the top miner was just submitting like from a bunch of different hotkeys 1,000 shitty agents to like kind of clog up the queue so that nobody better than him could get evaluated. Oh, okay, so this is very cool. This is like an iMessage chat where you can see what we sent to the model and what the model responded with, and like kind of the back and forth that led to the output. So if you scroll down here, this is what we gave to the agent, and then that's what the agent replied with. So I told it, okay, go read this file, attribute fits connect.py.
And so then you return this. So this is like a chat between the agent the and the validator sandbox.
This is a chat between the agent and the LLM in the sandbox. And this is real. This is actually what this agent did to solve this problem. So it's giving it a bunch of context.
And then it finally fixes this.
I think a little bit above it shows you what the agent wrote and the Sweetbench ground truth patch. Probably above the inference, I think. Maybe Aaron moved it. Above all of this, sorry. Let me just check where it is. Yeah, so
Here.
that's the expected solution, and this is what the agent wrote. But the agent solution was actually also valid. So you can see they're not just submitting like the Sweetbench gold patch either. And you can also inspect how they got to their solution.
It took 15 minutes. Wow. That's quite a conversation. That's quite an agent running.
Yeah. And it was
does
cheap. Like I
it
think
does suggest, yeah,
yeah.
you can go back to the agent and the cost was something like $1 or 25 cents, not even 25 cents.
No, way less. It's like a fraction of a cent. I think if you click on like that just shows you the code base. If you go back to the agent, there's like a little arrow there where you can expand the problem. You should probably have that expanded by default. Left of the kind of like the code base name. Yeah, the usage doesn't even show up. Oh, I don't know why the number of tokens is not showing. We just push the change. But like in general, the inference cost for these, so we've done 10 billion tokens. It's been less than 3K. It's extremely cheap. It doesn't even show up.
Wow. Should we go back to Keynote here and back to the presentation?
Sure.
Right.
I think I have like yeah, sure. But yeah, so we have like a bunch of things coming up right now for like how we plan to like kind of move forward and build the agents out. I think the clearest way that we can actually show that like we can build a product here that is better than like any centralized company is to legitimately rush towards a product. We have a bunch of unlocks on the way here. So this is what agents are currently doing, and you can see this in the inference pattern. It's trying to find where to edit code. It's attempting to solve it, and the only check that the agents have available to them right now is whether it's valid code. The reason for this is because we put them in a sandbox that doesn't have um, all the dependencies needed to run the code in the code base. You have some dependencies for your agent code, but nothing else. And so if you go to the next slide, we basically, and we shipped it this morning now, where agents have the ability to also run the code that we give them. The code base that we gave them, they can now run any of that, including all the tests in their code base and stuff. So it's a pretty clear disadvantage that our agents have that already they got to 41.2% without this. And now I think it's going to supercharge the performance where we kind of add this thing in the loop where they can find where to write and edit code. They attempt to solve it. They get to actually run that code in the sandbox to check whether the solution worked. And they can kind of like iterate the same way that a human can. A human writes code, they run the code to make sure it worked. And this is like a key part of the feedback loop that we need to give to agents that we've enabled today. So now they can also like run the code in the sandbox and also check if it's valid code, and then go back if they needed it. For example, if their solution didn't work, even if it was valid code. The next one and the biggest thing is kind of like rushing towards a product. So our performance is going up every day. We're going to keep evaluating harder and harder problems to get them better and better. We want to build something like Claude Code, but much more affordable. And I think we can actually do this in a more sustainable way for two reasons. For all these labs, they have two major costs, which we don't have. One is R&D. We're not paying like $100 million per engineer. Our R&D overhead is basically covered by the miners. They're the ones actually improving the agent and doing the research. And the second one is inference, which you guys can see like 10 billion tokens, $3,000 is extremely cheap for us because we're building off Bittensor. And it isn't a question of like, okay, we're using subpar inference. Like the inference is actually quite good, state-of-the-art open source models, and it's handling the throughput with no hiccups. So we feel confident that we can continue to use like the Bittensor inference as we build a product. We want to build a tool just like Cloud Code, where you open the Ridges tool in your code base. You can do it in Cursor, you can do it in your terminal, and then just like Cloud Code, you ask it for the features you want to see or the issues you want solved, because that's how the agent works right now. And then for the user, we will handle the upgrades in the background every hour of every day as someone submits a new, better agent. For that user, we will actually swap out the agent code for them in the background. And of course, we'll handle the inference for them through Shoots and Targon. And so every time a user logs on, the product gets better for them because every day the miners will have improved the agent performance. And now the user gets to see that improved agent. And also, again, like I mentioned, throughout the rest of the stack, it kind of got better. Like Shoots and Targons have newer models, they have better uptime, better throughput, better reliability. And ideally, like we're actually using trained models as well that we can swap out under the hood. We also want to kind of like we mentioned before that there's a big issue that Sweetbench has kind of been saturated. We want to build like the next Sweetbench, but on Bittensor. And we're kind of doing that as it is, so we may as well kind of release it to everybody. Where like we're kind of building like this eval that we're constantly editing to make sure that it's like state of the art and valid and not being exploited. And so, like for example, like we had that exploit where people would give easy problems to the model and it would one-shot it. And on top of that, we have a problem where if you look at like the top models across all the benchmarks, they're really built for that eval's environment. If you take the top Sweetbench agent and you try to run it on Polyglot, it doesn't do very well, and vice versa. We're trying to obviously build something that's a generally capable agent that can solve problems across benchmarks and in the real world, and not just do really well in one benchmark and fail all the others. And so we basically want to like take this eval loop that we're building on Bittensor and release it as an open source pipeline, where anyone can take an agent and put it in a fair sandbox that we've already developed across a bunch of different evals, Sweetbench, Polyglot, and this new one that we're creating, and get an actually accurate overall assessment of how good an agent is. I think that we can probably like replace Sweetbench as like the gold standard for measuring an agent's performance. Next slide, please. We're also so the miners are really good, but we want to also bring in like a lot of external researchers. Basically, like there's a lot of really good AI researchers that, for example, wouldn't work at labs or are just doing research on their own. That I think would be great to have them in Bittensor. Um, and I think this is like true of like specifically for our subnet, like AI agent development. There's definitely a lot of people interested in that. But this is also true of like just like a lot of AI research. And so I think there's a couple of reasons they're not here right now. One is that like obviously Bittensor is growing, but it's still pretty niche. Not a lot of people have heard about it. And two is that like crypto in general, for the most part, is a pretty, in my opinion, a pretty scammy place. Bittensor is like one of the few pockets in crypto that has a relatively low grifter percentage, and you can actually build like real things on it. And so our plan for this is basically as we release our product, every time someone logs onto the product, which they are going to be software engineers themselves, will have a big red or big green, earn $15,000 a day competing to make this product better. So they'll click into that, and we'll let them log in with their Google account and connect their bank account with Plaid, and we'll create like a dashboard for them, or we actually have created this, where they can submit an agent to the dashboard. We run like a validator loop where they can easily see how their agent's doing. And if they're the top miner, we will submit it for them on chain in a way that's verifiable. Everyone can see that everyone can see and run the code as well. So basically, we've abstracted wallets away for them, and we'll take a 30% fee. So that does a couple things. Obviously, it reduces like the sell pressure on our token. It allows like crypto averse researchers to actually start mining and do something productive and get involved. And I think that this fee is big enough that it'll get them to like, because we'll be very open about the fee. It'll get them to learn about Bittensor and like kind of they'll want to set up their own wallets and kind of get more involved with the ecosystem as a whole to avoid the fee. Obviously, register their own miners on chain. And so we'll be releasing that like in tandem with our product. Um, I think that's the last slide. So yeah, we have like a bunch of exciting stuff like that kind of coming together, I think.
Hoorah! Very exciting. I think maybe the first summit ever to try something like that to make it so that crypto averse people don't even know they're mining on Bittensor. What a fantastic idea!
Yeah, I think it'll be pretty cool. There's a lot, especially like in AI, there's a lot of people that are pretty averse to crypto. But I think that like if they start doing this, there's no reason why that narrative couldn't start to change, if they see that they're actually building a real product here.
Absolutely. It's always been an uphill battle for us at BitTensor, because even though we're building legitimate technology, we're actually doing decentralized artificial intelligence. We're serving billions and billions of inference tokens. We're training, best in class models. We're doing all of this
Yeah,
amazing stuff. And still, people
especially
crypto
with
just
crypto.
has such a bad name. Well
Yeah,
earned.
and I mean,
Well,
with good
well,
reason. Yeah, exactly.
very well earned. I mean, just look what happened the other day on 46, right? This is just the world we live in permissionlessness. People can come in and they can say things, and within 10 minutes, people can lose a bunch of money, as an example. But then, so obviously, this is not what you guys are doing. This is fantastic. You have this team building this like real technology, and we're getting to 40% on Sweet Bench, and even at the disadvantage, right? Like we can't even
Yeah,
do these
you can't
multi-step,
even check it.
training and exactly. And then this is only in a couple of days. Like it really shows how when you get the incentives correct, um, things move very fast. But when you don't have the incentives aligned, you're just stagnant. Like you guys as a team were stagnant for many months on BitTensor. In fact, you guys gave up,
Yes, yeah. So
right?
I actually ended up doing a buyout of my team, and like I run the subnet like myself now with this new team that I've hired. It was kind of like DTAO started, and we were just like we just figured out pre-DTAO how to like run the subnet, and then it was kind of like oh shoot. But yeah, I thought it really had potential, and I wanted to run it like, so I bought my partners out, and just kind of used my savings to like start it up again, and it worked out really well. I'm really glad that I did it. It's been a really cool ride so far.
So the rest of your team, these are all friends of yours from Waterloo, or you hired them? They're just random engineers in the town.
Yeah, basically. I actually did the same thing that I'm planning to do with like external researchers with my team. Every one of them said that if I told them it was crypto, they would not have joined. Um, but basically, like I put it out on Waterloo Works, which is Waterloo University's like portal to like hire Waterloo students for internships. And I explained it as like competition to build AI agents, and a bunch of people applied. I read all their code and I hired the three best ones. And yeah, like just random Waterloo engineers. But I mean, not random anymore. We all like live together and have for the past couple months, in my basement.
Yeah, the iteration speed is fantastic from the subnet. I mean, things are going very well. It's amazing to have you up on stage, um, and you know, maybe we get the whole team next time. You know, we're way over time, but it's
Okay.
been really fantastic a presentation. So, and I'm looking forward to this Cloud Code competitor, so I can use it myself. Stefan, any like final remarks from yourself?
We've got a recurring question from the community that I will be lynched if I don't ask, and it's about plans to control emissions to keep the subnet productive. I know that this is a bit of a knife edge that you have to tread as a subnet owner, but there's a question here about what do you plan to use emission burning to keep the subnet, I guess, focused on certain initiatives, or you can sort of interpret that as however you like.
Absolutely not. No chance. Where even during upgrades, we don't pause emissions. I think that like our whole thesis is that miners are like our lifeblood and they do the R&D for us. Um, and so it doesn't make sense, I think, to like to cut their emissions to try to help the price. At the end of the day, I think that like if we align the incentives right, they'll build a better product and they'll actually help us create a product that'll generate massive revenue. Companies that are doing this are like some of the fastest growing companies of all time, and that'll flow right back into the token. And that's a better way to kind of like control the token rather than burn miner emissions. So yeah, no chance we burn any amount of emissions, miner emissions.
The audience is pleased.
These guys are my team.
Yes. And also, I agree with Tim's perspectives that burns don't make it. Like, if you have a mechanism where miners, you know, obviously and always drive themselves to 100% sell pressure. Like, look, commodity subnets are a perfect example, right? Where you know, like on perhaps on Targon or on Celium, as good examples. Like if you send out more emission, the miners are ultimately just going to load more compute on, and then that becomes more cell pressure. That's not the case with something like Bridges. You know, it's an
Yeah,
innovation one,
we're
and you guys
actually
are distributing ownership out to your community, which is it's very intelligent. It's like the side I'm on and always have been in this debate.
yeah, and
But
miners
like,
are
yeah,
actually holding more and
the
more of
chat
our
loves you
token.
for this.
Oh, yeah. Yeah, the miners are actually holding a
Yeah,
lot more of our token because their costs are very low as well. A lot of them are very aligned. And yeah, like you can see like the percentage of token that they're holding is just like kind of going up day by day. Like they're selling less, especially because their costs are very low. Inference is cheap, so it's just the R&D cost for them of like doing the research, the time that they're putting into it. But yeah,
cool.
cool.
Any more questions from the chat here?
Weight copying validators. So our vtrust is basically one now. Everyone is the variance is low enough that the validators are settling on the same top agent. And so thankfully, like a lot of stake has moved. It used to be the case that our vtrust was unstable, and so the weight copiers had the highest APY. But we fixed that now for a couple weeks, and since then, like their stake has been dropping. But if you do have ridges and you stake the Tau 5, please move it away to like Roundtable or OpenTensor, or someone else. The winner, it does become easy for weight copiers, but it also becomes easy for honest validators to become stable, because it's winner takes all, and that kind of fixed our vtrust for us. Um, but yeah, but because it's pretty stable, there should be like no advantage to to weight copying now, ideally.
I typed into the chat that you guys are going to have your Cloud Code competitor in 1 week. That might be a bit unfair. What actually is the launch date?
I mean, we can do it MVP for sure in a week. It comes down to how good the underlying agent is, and we'll probably need to do an agent upgrade, but we can try for like perhaps like 2 to 3 weeks from now to get something that people can use in the community, easily install and run in Cursor.
That would be fantastic. I mean, I think it would tell you also about whether or not you're overfitting to suite. I mean,
Yeah.
my guess is we are, right? You know, it's like when you put this thing in practice, oh, that's a bad idea. It's too expensive, um, or it actually just can only solve suite bench problems and not what people need, right? Um,
Yeah, we definitely want to
it,
dog food this as fast as possible as well and see whether it like passes the smell
mhm.
test.
Cool. There's a couple people typing here. I'm going to wait just a moment.
It's good.
While we're waiting on that, I've got a question for you. So it's really cool to see more subnets sort of connecting together and supporting each other through tokens and through lots of other stuff. Could you see a state where you are actually providing intelligence to another subnet that's doing a higher level task or something that depends on agents sort of optimizing certain solutions?
Yeah, for sure. There was actually one subnet that I was talking to about this where we could kind of like they were doing like QA agents where the agent kind of like tests a website and finds things that are broken. And I had an idea of like kind of combining the two, where like the QA agent gives our agents a list of problems with the website, and then we take the website code base, we give it to our agents, and it goes through the problems and tries to solve it. I also think ideally, like if the agents get good enough, there's no reason why people couldn't use them to basically form miner teams as a solo miner. You take like these agents, and a miner has to do like a bunch of stuff on different subnets. But if this agent can write code just as well as they can basically now have like a miner team at their disposal by just downloading these agents and using them as engineers.
Subnet 62 mining Bittensor. That's nuts.
Yeah, it would be pretty cool. I don't think we're there yet, but I don't see why we can't get there.
Wow.
What if someone
Very meta.
we do so someone asked a question, what if someone writes a good agent and you updated your allowed models in the repo and someone takes the best agent code but only changes the use model. It creates some kind of rat race. This is true. But the thing is that like oftentimes the person that will a person with a better agent architecture will ask us to change the agent to change the model or allow models on a whitelist, and also like there aren't models coming out at such a crazy frequency, so we try to add them as quickly as possible, and everybody can kind of like submit the same agent. But it is possible that someone gets like really bad timing where they submit this better agent, and then right after we approve a new model, and then someone else submits their agent with that better model. And that is like a valid upgrade. But I think that it's also possible for the person that originally submitted the model to also submit it with that new model.
Get started, guys. Go mine 62. Hell yeah.
Yeah.
Great presentation. Amazing novelty search. Thank you, Stefan, for hosting with me. Plasma, as always, man, really great. Thanks everyone
Awesome.
for coming as well and the
Thanks, guys.
questions and staying late. Bye, everyone.
Cool. Thanks, guys.